What do you mean by complement of a system? Try to observe. If I am going to have a number like x, what is the complement of x? I can represent like x complement, x bar, which you heard in probability and statistics, right? So if I am going to have a probability of x is to 0.2, what is the other value of the probability? 0.8. Meaning that if I know the value of 0.1 value, I can able to get the value of another value. Meaning that if I know the complement of one variable, I can able to get the actual value of one variable. If I know the actual value of one variable, I can get its complement. Am I right? Yes. See, here similarly, if I am going to have a number like base 10, a number like base 10, whose actual number is 84. Actual number is 84, right? If you would like to find out the complement, if you would like to find out the complement, so how can we get the complement of a particular number like 0.2? 1 minus 0.2. What is this 1? Maximum possibility value, maximum probable value. Similarly, what is the maximum probability value of a number if it is in decimal digit number? If it is 10 tens base, we have come across that terminology already, right? If its base is 10, the maximum possible number is 10 power n minus 1, 10 power n minus 1, which is equivalent to double 9, right? If it is two digit number, right? So that is what, right? 10, if it is two digit space, I can able to get a maximum digit of 99. If it is three digit base 10, you will get triple 9. If it is something like base 6, maximum possible value is triple 5, triple 5. So what they are trying to do here in probability and statistics, they are trying to subtract it from the maximum value in order to get its other value, right? Similarly, if I want to get the complement of a particular number, what you have to do? You have to subtract it from the maximum possible value. What is the maximum possible value? 99. 99. From this 99, you have to subtract 84. 84, you will get 5 and 1. 15 base 10 is the one complement of 84. Is the one complement of 84. Right? Meaning that I can write 84 in terms of another form as 15 base 10. Right? If I would like to get the complement 84, actually what you can do? You can simply subtract again 99 from 15, you will get again back. That is what, right? If you know 0.8, if you subtract 1 minus 0.8, again you are going to get 0.2. 0.2, right? So this is the way you can able to find out its complement. Its complement, right? So here I have used two terminologies. One is b minus 1's complement, another one is b's complement. Meaning that you can able to represent any number in the system in two formats. One is b minus 1's complement format. Another one is b's complement format. Right? So if you are going to perform it in the form of b minus 1's complement, you have to subtract it with the b power n minus 1 minus x. Is it correct? What is b here? Some radix b. I am trying to think that it is some radix b. N means number of digits, minus 1 means b power n minus 1 is the maximum value I can able to get. X means what? The number which you want to find out the complement. So the same, this logic I have written in the form of a formula. So this one I can call it as b minus 1's complement, and I can alternatively call it as what? 9's complement. 9's complement, right? What about the b's complement means? Simply we can able to write as b power n minus x. Right? Why you are getting it as? See, earlier you have studied already. If I am going to have a number like 1 1 1 1 base 2, base 2, right? Meaning that it's a binary number. What is the complement of 1 1? Basically, you know, 1's complement you can able to write, 2's complement. 1's complement means exchanging of 1's with zeros, zeros with 1's. So 1's with 0, 1 with 0. This is what? 1's complement. How we are going to get the 2's complement? By simply adding plus to the 1's complement. Can you able to get the 2's complement? Yes, right? So 0 1. This is what? 2's complement. This logic you know or not? If you are going to exchange 1 with 0, 0 with 1, you will get the 1's complement. If you studied it earlier, right? If you are in studied earlier, I can derive it for once again. Try to observe what I said. You have to subtract it from the maximum possible value. What is the maximum possible value I can able to get if the base is 2 for a 2-digit number? Again 1 1. 1 1. From 1 1 what I have to do? I have to subtract again 1 1 x. So are you going to get 0 0 or not? Yes. 0 0. Then it is called as 1's complement. For this, if you are going to add plus 1, I will get 2's complement. See, observe here for b power n minus 1 minus x, if I am going to add plus 1, are you going to subtract these two cancel? Then you are going to get b power n minus x or not? That is the complement, that is the b's complement for a radix b. Radix b. So try to solve this one. 45 base 10. See, if I am trying to say a number with base b, how many kind of complements will you going to get? 2. One is 9's complement is one possibility. Another one is 10's complement. 10's complement, right? Which one is the better one? That I will explain in the later part, right? So what is the 9's complement of 45? Simply you have to subtract with the 99. 54. So just try to go with the procedure first. Next, what is the 10's complement of 45? 9's complement plus 1. So 55 base 10. Base 10. Okay. So try to solve this. For example, I am trying to have a number like 1 2 3 4 base 8. If I am saying that it's base 8, two kind of complements are possible. One is 7's complement and one is 8's complement, right? What is 7's complement value? You have to simply subtract with the maximum possible value. Maximum possible value is 8 power 4 minus 1. See, you are going to get confused here. 8 power 4 minus 1 is what? Decimal format. This is decimal format. Again, if you are going to convert into octal format, then you will get the value as 47. That is the maximum possible value you are going to get. From that, you need to subtract 1 2 3 4. So you are going to get 6 5 4 3. This is 7's complement. For this, if you are going to add plus 1, you are going to get 6 5 4 4. This is 8's complement. Okay. So try to do this. 121 base 3. What is the complement of 121 if it is base 3? So you are going to get again 2's complement as well as 3's complement. If it is 2's complement, you need to subtract from all 2's. So 1 0 1 base 3 1 102 is 2 is possible here? Yes. 102 base 3. 102 base 3. Okay. So this way you can able to get the complement of a particular number. Is it okay? Yes. See, now meaning that if I am going to have a number something like x, that number I can alternatively represent in the form of a some other form like y, so that I can able to use the same circuit for any kind of number. For example, let me take the same number again, 84 base 10, 84 base 10 and 6 base 10, 6 base 10. I would like to perform subtraction operation. What is the result? Right, it is direct answer because they are in our understandable format, that is base 10. As base 10 I can able to directly solve. So you are going to get the result as 78 base 10, 78 base 10. But if you observe guys here, so the same number I have to write in two ways. One is 84 minus 6. So while performing subtraction you have to use some other kind of circuit, is it right? Instead of that I can represent like this, 84 plus of minus 6, plus of minus 6. This minus 6 also I can write it, its alternative, its alternative, its alternative means what? Some complement value, some complement value, right? So for minus 6 complement value you have to find first, right? So if I am going to find out the complement of minus 6, right? So actually 84 base 10 is as usual. For 6 base 10, 6 base 10, what is the complement of 6? So 99 minus 6, right? So okay, fine. So as per understandability it is single line only. Single line minus 6 is 3, 6 is 3. But while trying to perform any kind of addition or subtraction in any kind of computer systems, you have to make it equal number of digits, right? So then I can able to make here as 06, right? Then 99 minus 6 is 93, 93 base 10, meaning that what I did here, I have represented minus 6 which is in the system to positive number is equal to 93. Positive number equal, meaning that 93 is the complement of minus 6. Right? Now I can able to simply perform addition. Right? Now you can observe, right? The same data I have used only the same circuit, that is of addition circuit. Now try to perform addition. 4 plus 3 7, 8 plus 9 17, 177. But what is the result we are expecting here? 78, 78, right? So here what is the maximum space available for us to store the data? 2 bits are enough, 2 bits are sufficient, but extra carry is forwarded. This is what I can call it as overflow, overflow, meaning that it is not sufficient to store the remaining data. That is one I can call it as overflow, right? The extra bit I can able to add it to the existing location space. 77 plus 1 is 78 base 10. Is these two are equivalent or not? But here computer what did? Is it done any kind of subtraction here? No. Just make it as addition only. But are we going to get the result or not? This is what the advantage of complementary of a system. Okay. So try to take out one more number, the same number, 06, 84. Both are of decimal number. I am trying to perform subtraction. What is the result you need to get? Minus 78 base 10. This is the result you need to get. See, observe here. So for negative number you have to find out complement. 06 for 84 complement is 99 minus 84, 15, 15, and then you simply perform addition. Addition. So total is what, ma? 21, which is base 10. Is it equivalent? No, it is not equivalent. Then what you have to do? Can you find out any relation between these two? Complement of 21 is 78 or not? Yes. So what you can do now, simply you can perform again complement of the result. Complement of the result. Complement means from which number you need to subtract? 99. 99 minus 21 is 78 base 10. What about negative? how can we tell it is negative number or not? See, observe here, this is normal 6. Normal 6 means normal base x. Is it okay? Normal x. And this 15 is what? Complement of one number called y. I mean, I am assuming that 6 is x and 84 is y. What is complement of y? Complement of y. 15, okay. What is the formula that we are trying to derive here? 10 to the power of 2 minus 1 minus y. Minus 1. Right? So, here you can observe one important point. If you are trying to do, if I am going to have a number x and I am trying to perform complement of x, what you need to get here? 0. I need to get here 0. Right? So, x and minus x, when you perform addition, you need to have 0 only. So, we can simply call it the additive inverse. Right? If you take the value of x, what is x? X bar? B power n minus 1 minus x, which is equivalent to 0. If you are going to remove this one, what you are going to get here? B power n minus 1 is equal to 0. Meaning that when this particular equation is going to be satisfied, when you make b power n minus 1 is equal to 0, b power n minus 1 is equal to 0, then only our statement is correct. Then only our statement is correct. Right? In addition, in another form, what is b power n minus 1? Which is equal to x power n minus 1? Maximum number, right? So, for example, if it is 2 power n minus 1, where n is 4, what is the maximum number? 4 ones. 4 ones. What, according to this formula, what we are trying to say? This is 0. And if you observe the same 4-digit number, can we get any 4-digit number like 0000? Will you get the value 0 or not? Yes. Meaning that in this particular representation, this is what kind of representation? B minus 1's complement. In B minus 1's complement, we are going to have two patterns. Which will be directed to same number. Is it a valid thing? No, that is not valid. So meaning that this is invalid kind of design. I hope you understood, right? So actually, with one kind of procedure, you are going to get the value 0. The same thing you are going to get with again 4 ones, but that is not the correct one. So this is the drawback what we are facing in b minus 1's complement. B minus 1's complement. Here try to observe, according to this logic, b power n minus 1 equal to 0, we are trying to simply make this as 0. We simply make it as 0. Meaning that 6 plus 15 is 21, which I am trying to say that x plus b power n minus 1 minus y. I am going to make this as 0, which is 21 base 10 x minus y. Am I right? Yes or no? Now, for this one I am trying to find out complement. What is the complement of 21? 78 base 10. If I am going to find out the complement of 21, what about the complement of x minus y? Opposite sign, right? That is minus of x minus y, right? So if I remove the minus here and if I move towards right side, x minus y equal to minus 78 base 10. Minus 78 base 10. So this logic you have to follow. So once you perform complementation, then again you have to append minus. So you are going to get as a minus 78 base 10. Okay. See, observe. So let me take one more example. Can you tell anyone any example? Any number? 43, 76. Okay. Both are of base 10. I am trying to perform subtraction. What you have to do, ma? So for negative number, you have to find its complement so that you will get the positive number, right? So 76, try to tell, 76 and 99 minus 43 is 56. So value is 12. 7 5 is at 7 5 12. 12 plus 1 13. You got the carry. You can simply add here so that you will get 33 base 10. So this is also equivalent to this one. So our trying to do solving the procedure is correct. Okay. The same thing try to do in another format. Reverse 43 minus 76. You need to hit minus 33 base 10. So 43 is as usual. Minus 76 complement is 23. If you are going to add 66, right? So do you got any kind of carry here? If there is no carry, you have to first find out its complement, that is 33, which is x minus y, which is minus of x minus y. Complement is minus of x minus y. So you are going to get x minus y as minus 33 based. Minus 33 based. Okay. Now. See guys, here I will derive one procedure here. Try to observe. When you are trying to perform subtraction, try to first find out the complement of a negative number. Find out the complement of negative number. After finding the complement of a negative number, whatever the result you got, if the result is going to generate any kind of a carry, remove that carry and simply add it to the result so that you will get the result. You will get the actual result. Similarly, see, observe here. Here this is what value ma? X. This is b power n minus 1 minus y. Minus y. Right? I am trying to make this as 0. So I am going to get x minus y. If this x minus y generates a carry, I will simply add it to the plus 1. If it is not going to generate a carry, I am going to simply find out its complement and I am going to simply append its minus 1. This is the procedure you have to follow while trying to perform subtraction to any kind of number system data. So, see, first one, try to find. So I am trying to tell for b minus 1's complement procedure. First find out b minus 1's complement number, and then if you are going to get the result x minus y result generates a carry, then you need to add it to the result. You need to add back to the result. That itself as a final result. Right? What is another case? If x minus y doesn't generate a carry, meaning that if it is not going to generate an extra bit, you can simply, you need to find out first complement. You need to first find out complement, then you need to add negative symbol, then this will be your final. These are the two steps that you have to follow. Okay, see, try to solve the another one. Any number you can give. 121 and 110, not base 10, both are of different base. Try to perform subtraction. See, I will try to tell this one also. See, what is the values after subtraction? Right, 121 base 3 in decimal format. You have to perform multiplication, right? 1 plus 6 plus 9. 16. Very good. 16 base 10 and 110. 3 plus 9, 12 base 10. If I am going to perform subtraction, you need to have 4 base 10. You need to have 4 base 10, right? So now try to do the same procedure what we did. First 121 as usual, and what about 110 in in its complement form? You have to subtract with the maximum positive value. Maximum positive value is triple two. Triple two. If you are going to subtract 1, 1, 2. 110 in decimal format is 13. 3 plus 9, 12. 0, right? Okay. So here the maximum positive value you are going to get triple two. From triple two you are trying to subtract 110, you are going to get 112. And then you are going to perform addition. If you are going to addition, what is the value you are going to get here? 3. 3. But is it correct? No. In if a so in base 3 radix system, there is no number such that which are greater or equal to 3, right? Then what you have to do? Again you have to convert into base 3 format. 3 you have to convert into base 3 format. What is the value? 3 convert into base 3 value. I think 10. Okay. Is it okay na? 3 converting into 3 1 0 3 1 0. This is in base 3. Now try to observe 4 you got. 4 is available. 4 is not available. Then what you have to do? You have to convert into again base 3 format. Base 3 format 4 3s are sorry 4. If you are going to do it with 3, you are going to get 1 1. Now you got 3. 3 is available once again? No. Then what you have to do? You have to again remove this and you have to modify it with the base 3 system, that is 1 0. See, 1 is carry, that I made it directly here, right? So now according to our algorithm, if you are going to have a carry, what you have to do? You have to simply add it to the plus 1, that is 0 1 1, which is in base 3 system, right? Now in decimal system our value is 4 base 10. Is these two are correct or not? Try to cross check. What you have to do? Base 3 system trying to convert to decimal system, simply multiply with powers of 3. Are you going to get the 4 base 10 or not? So whatever the algorithm that we are trying to learn here is perfectly correct. If it is in b minus 1's complement. Okay, so try to do this one. See, up to now we have seen b minus 1's complement. Now let's see b's complement procedure. (84) and 6. (84) minus 6. What you have to do, ma? 84, okay. 06. Earlier you have written in the form of 9's complement. Now we need to try to write in the form of 10's complement. For that, what you have to do? 9's complement plus 1. That is 93 plus 1. 94. 94. Now we can able to perform addition. Are you going to get 8 and 178? What is the result of actual data? If it is in base 10, 78, right? So we got the data other than the carry. So we can simply discard this. There is no need of this one. Okay. Similarly, try to take out 06 minus 84. You are going to get minus 78 base 10. 06 is as usual. 84 complement is 84 b's complement means 10's complement. So 9's complement is 15, 10's complement is 15. So you are going to get 21, right? Which is not our expected result. So again you have to take its what? complement. So 10's complement is 16. 9's complement is 15, 10's complement is 16. 16 plus 6 is 22. 22. 22 is exactly complement of 78, right? So what you have to do here, you have to perform complement. Complement, if you are going to do, you are going to get 78 base 10. But if you observe here, this is x, this is b power n minus 1 minus y. So this is what? 16, sorry, b's complement. So b power n minus y. So we are making it as b power n as 0. Why we will make it as b power n as 0? To make x plus x complement as 0. To make x plus, see, if I am going to have x plus x complement as 0, x is as usual value, b power n, x complement is what? B's complement, b power n minus y, right? If I want to, if I want to make, if I want to make it as 0, b power n should be 0. That's why b power n at 0, that you are going to get as x minus 5. X minus 5. If I am going to try to perform complement here, this should be minus of x minus 5. So x minus y is what? Minus 78 base 10. Minus 78 base 10. So try to take with another example. Uh, this one, 76 and 43. What is the value? 76. This is 54. Sorry, 56. 56 is 9th complement. 57 is 10th complement. So 13, 133, 1 discarded. So are you going to get the result or not? Yes, 1 discarded. Similarly, 43 minus 76. So 43, 23 plus 1, 24. You are going to get 67. You need to find out its complement. That is 33. Further, you need to append minus. Right? So means here what you have to do, ma? If it is in B's complement, if it is in B's complement, when you are trying to perform work with B's complement, try to find out first B's complement for the negative number. After that, whatever the number that you are trying to subtract, the result will be, if it is going to generate a carry, just discard the carry. That is second step. If there is no carry, if there is no carry, you have to find its complement. You have to find its complement, and then you have to add sign. This is the final result. Final, right? So this is the way you can able to perform subtraction of a number in any kind of system, operating systems. Okay. So finally, I can conclude that like any kind of negative numbers are stored in the form of complements. You can be able to store in the b minus 1's complement or in the b's complement. If it is going to store in the b minus 1's complement, what is the problem? Observe here. Observe here. According to our assumption, the same two patterns, 4 ones will be equal to 0 and 4 zeros also will be equal to 0. Whereas coming to in b's complement is that it is possible b power n is equivalent to 0. What is b power n? See, b power n minus 1 is the maximum possible number. After that, next number you are going to get is the next number as b power n. So, first initial number is 4 ones. Next, whatever number next number you are going to get, that is 10000. Our system is capable of storing only 4 digits. Then what is this value? 0. 0 is equal to 0 only. So, all 4 zeros equal to 0. This 0 is also equal to 0. There is no problem in that. So this is correct. So that's why most of the systems are all following B's complement only, and this is the most useful one.